In this video, we're going to look at bounds of measure. So when measurements are recorded, they're usually given to a nearest unit. So for instance, your height could be 173 centimetres to the nearest centimetre. When we give a measurement to a certain degree of accuracy, the actual value lies between the rounded value and plus or minus half the rounded interval. So if we're thinking about that 173 centimetres, the bounds are 172.5 and 173.5. And the reason for that is that if we've got 173 centimetres and we're looking for the values that round to 173, we could be thinking about 172.9, 172.8, and all the way down to 172.5. So all those values will round up to 173 to the nearest centimetre. On the other way, thinking about the values that round down to 173, we've got 173.1, 173.2, 173.4, but I'd say we've got 49 would be bigger, and 499 would still be bigger and is less than a half, so it's not going to round up. 999, another 9, and another 9. So what we've got is that an infinite number of 9s after that could occur, and that value would still round to 173. But it's not very practical to talk about 173.4999, especially whenever you're using it in calculations. So the way that we get around that is to say that, well, 175 is the smallest number that won't round down to 173. So if we call 175 as our upper bound and use the less than symbol, then that makes life an awful lot easier. So what we're saying is that 173 can be everything down to and including 172.5, but it's not going to be equal to 175. So anything just less than that, so 0.000001 is going to be less than, or away from 175 is going to be less than it, as is this number here. So the 175 is a lot more practical. So we say that the lower bound is less than or equal to the measurement, which is less than the upper bound. And the difference, notice the difference as well between our bounds is 1 centimetre, which is the degree of accuracy. And the difference between those and the rounded value is half of the interval. So what we're doing is we're halving plus or minus half of the rounding interval. So if we're rounding to the nearest 10 centimetres, half of 10 is going to be 5, so we're looking at plus or minus 5 of the rounded value. So we're going to be 175 and 185. Now remember, 185 would actually round up to 190, but the way we're writing this is 175 is less than or equal to 180, which is less than 185. So it's much easier for us to use that. The next one then, we're to the nearest centimetre. So half of a centimetre is 0.5 centimetres. So we're going to have 179.5 and 180.5. Again, it can't equal 180.5, the upper bound. It's going to be less than that. But the difference between lower and upper bound is now 1 centimetre. To the nearest 0.1 centimetres, again, we're going to look at halving our rounding interval. So if you divide 0.1 in 2, we get 0.05. So 180.3, the lower bound is going to be 180.25, and the upper bound 180.35. And again, the difference between 0.25 and 0.35 is 0.1. 150 rounded to 2 significant figures. Well, that really, in this case, if it's 2 significant figures, the rounding has gone on between the 5 and the 0, so that's rounded to the nearest 10. So half of 10 is 5, so we're going to be looking at plus or minus 5. So if we take 5 away from 150, the lower bound is going to be 145, and the upper bound is going to be 155. So in other words, if we look at 145, the 1 is the first significant figure, 4 is the second, 5 is the third. So if we look between the 4 and the 5, that means we round up, so it's going to go to 150. Again, 155 would technically round up to 160, but because of the less than symbol, then we're fine. And then the nearest 0.5 kilograms, so again, half the rounding interval, that's going to be 0.25 kilograms. So if you take that away from 15.5, we're going to get 15.25 kilograms. And then the upper bound is going to be 15.75 kilograms. And again, the difference between our bounds is 0.5 kilograms, and we're plus or minus 0.25 from 15.5. So we've looked at how to work out bounds. Now we can look at how to work with bounds. So if we're trying to find the maximum of two different values which have already been rounded, the maximum value of A and B is the maximum value of A plus the maximum value of B. If we're looking at the maximum difference between A and B, what we're going to have is the largest value of A minus the smallest value of B. So if you're looking for the largest piece of pie, you want to take a large piece and then take a very small bit away. If you're looking for the maximum value of A multiplied by B, it's going to be the maximum of A multiplied by the maximum of B. Whereas if you're dividing and you want to have the maximum value, so sharing money between friends, you want to share an awful lot of money between few friends for you to get the biggest share. So it's going to be the maximum of A divided by the minimum of B. If you're looking at the minimum value of two ones added together, it's going to be the smallest of those two values. So it's the minimum of A plus the minimum of B. And if we're looking at the minimum difference, we want A and B to be close together. So we're going to want a small value of A and a big value of B. If we're looking at the minimum of A multiplied by B, then we're going to take the smallest A and the smallest B. Whereas if we're looking at the smallest division, so if we've got an amount of money and we want to share that, to get a small amount, we want to start small and divide by a large number. So it's the minimum divided by the maximum. So what's the maximum volume of a cube whose sides are 12 centimetres to the nearest centimetre? So what we can do is 12 centimetres to the nearest centimetre. Centimetre is a rounding interval. So if you divide that by 2, we get 0.5 centimetres. So our lower bound and our upper bound is going to be 11.5 and 12.5. Because we're looking for maximum volume, we're going to use the upper bound. So the maximum volume is going to be 12.5 cubed, which is 1,953.125 cubic centimetres. We've also been asked to work out the minimum surface area. Now the surface area of a cube, what we've got, those are all the faces, and what we have is 6 squares. So we're going to multiply 6 by the minimum surface area, and that's going to come from the lower bound. So it's going to be 11.5 squared. And if we multiply 11.5 squared by 6, we get 793.5 squared centimetres. And that's going to be the minimum surface area. Example 32, John is 180 centimetres to the nearest 10 centimetre. So 10 centimetres, to find the bounds, we do half of that. And we're going to go plus or minus 5 centimetres. So we've got 180. So John's lower bound is 175 centimetres and the upper bound is 185 centimetres. Claire is 160 to the nearest 5, so her rounding interval is 5, and we'll half that to get 2.5 centimetres. So Claire's lower bound is going to be 157.5 and upper bound is 162.5 centimetres. So what is the smallest range? So range is largest minus smallest. And to get a smallest value, we're going to do the minimum of John minus the maximum of Claire. So that's going to be 175 minus 162.5. And that gives us 12.5 centimetres. And that's the smallest possible range between their heights. Example 33, a car travels 200 kilometres in 2 hours. What's the maximum minimum possible speeds? So what we have is that speed equals distance divided by time. So we're going to have to divide the distance by the time. Now, 200 kilometres, if we're thinking that it is a possible value that's been rounded, The smallest possible value that would round up to 200 is 150 kilometres, and the largest possible value would be 250. Similarly with 2 hours, if we're rounding to the nearest hour, we'd be thinking that the lower bound would be 1.5 hours and the upper bound would be 2.5 hours. Now, to work out the maximum speed, the maximum possible value is going to be the maximum distance divided by the minimum time. So that's going to be 250 divided by 1.5, which is 166.67 kilometres per hour. Whereas if we're looking for the minimum speed, it's going to be the minimum distance divided by the maximum time. So that's going to give the minimum value. So whenever we're dividing and we want the smallest value, we want to start small and divide by a big thing. So the minimum distance is going to be 150 kilometres. The maximum time is 2.5, which is 60 kilometres per hour.